Greetings from Clemson University. My name is Pam Stecker, and I want to provide an introduction for an article that I wrote with Lynn and Doug Fuchs entitled Using Curriculum-Based Measurement to Improve Student Achievement, Review of Research. This article was actually a solicited piece, as the editor of the journal had asked Lynn if she would write a manuscript about CBM research. I had been one of Lynn's and Doug's doctoral students, and I had focused on CBM and its effects on student achievement for my dissertation in the early 1990s. And so Lynn thought I would be interested in being first author and develop this manuscript focused on CBM and student achievement. I based much of this paper on the literature review that I had conducted for my dissertation, and then updated it to include work that continued in the 1990s in general education classrooms with class-wide CBM. In this paper, we synthesized experimental contrast studies that compared students with disabilities whose teachers used CBM against students with disabilities whose teachers used their own methods for progress monitoring, a business-as-usual contrast. We included studies in reading and in mathematics, but only when student achievement was one of the outcomes. We also discussed particular features associated with CBM that appeared to contribute to student growth. This review includes studies in which teachers applied systematic, data-based decision rules for instructional planning, had skills profiles of students' CBM performance available, or teachers may have been provided with recommendations for instructional changes based on student performance. Another outcome of this paper, though, is a description of CBM history that follows a line of research across a couple of decades. These studies follow a progression of CBM development, starting with measures and procedures in the mid-1970s that Standino and his colleagues and students developed, and one of those students was Lynn Fuchs. They focused on developing reliable and valid tools and procedures that special educators could use easily to monitor student growth. And at that point in time, measures were all administered and scored by hand. In the 1980s, Lynn and Doug Fuchs and Carol Hamlet at Vanderbilt University focused on computer applications for CBM. I was a doctoral student working with them at that time, so I was able to be involved in their line of investigation that examined the ease and efficiency of computerized test administration, scoring, and data management, as well as the use of database decision rules for determining when to make instructional changes or when to raise student goals. We added computer-generated skills profiles of students' CBM performance, as well as an expert system for producing instructional recommendations. And as more and more of our students with disabilities were being included in general education settings, general education teachers had greater access to CBM data, and they started asking for these kind of data for all of their students, and also for help in developing interventions that they could use class-wide. So we worked on a Peabody version of class-wide peer tutoring, which is now known as PALS, to enable teachers to provide differentiated practice activities feasibly. We used CBM data for recommending the skills and student pairings. As you read this article, I hope you will find it interesting to trace some of the history of CBM, and that you will be able to see how investigations can inform the next steps in an entire line of research. And I hope you will be able to be convinced that teachers' systematic use of CBM data for instructional decision-making, that is, progress monitoring data to individualize instruction, really can make a difference in student achievement.